Alright, find the average rate of change. Average rate of change is just W of 7 minus W of 1 over 7 minus 1. Which gives you the natural log of 7 minus the natural log of 1 over 6. And since the natural log of 1 is 0, it's just the natural log of 7 over 6. And if you wanted to calculate it, it's fine. You can leave it as that.
If you want to calculate it,
you can leave it at that. I don't care if you write the decimal. As long as you show that step, the natural log of 7 over 6, you should be fine.
let's see.
Lesson 2. I've already done. I've already had the play.
No.
You're not gonna.
So, S of 5 minus S of 1 over 5 minus 1. S of 5 would be negative 25 minus 5, so negative 30 plus 4, which is negative 26. S of 1 would be negative 1, it would be 2 over 5 over 4. So we get negative 28 over 4, which is negative 7. But because this time we have units, make sure you do feet per second. If you are missing units, you will lose points. 5 squared is 25, so that makes this negative 25. Minus 5 plus 4 gives you negative 30 plus 4, which is negative 26. Yep. No, I'm going to tell you, I don't think those 2 questions are on there on the test. I don't think they are. I know, that's why they're probably not on the test. Probably not on the test, no. I mean, you should be able to find slope. You do have questions finding slope. Okay? But I think, let's see if they're on here. It's going to be more like this question 18. Okay? Than it is the first 2 questions. All right. So find the derivative. Now, on the test, you are not going to have to use the limit definition of derivative to solve and find the derivative. What you will have to do is set it up and simplify. Okay? And it's one of your multiple choice questions. Okay? So, we need to find f of x plus h, which gives you 2x plus h squared plus 3x plus h minus 1, which is 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1. Yes. So when you put this in, what I need to see at the end of this, because it will be multiple choice, is the limit as h approaches 0, because that's what this is, h approaches 0, of 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1 minus parentheses 2x squared plus 3x minus 1 over h. That's as far as you'll take it. Yeah, I mean, on here, yeah, you should, but on the test, that's as far as they go. It's really, there's no point. Could you just look at it and tell me what the derivative is?
Yeah.
Yeah, use the power rule. It's what, 4x plus 3, and that's what you should end up with. So that's why there's not going to be this question on the test other than just setting it up and selecting the right one. Are there applications of the limit definition of derivative that are useful? Yes, but not often.
Okay.
Yeah, you should be able to look at this and get the derivative real quick. Yeah.
I thought you were talking about the form box.
No, I mean, no, from the original function. You should be able to look at the original function and go, oh, it's 4x plus 3. So that's as far as you need to go. I'm not going to go any further because you do know you're going to get 4x plus 3. I'm not going to waste your time with this. All right. These questions out. You will have this question, and I'm going to make sure you really do pay attention to the important parts you need to have. Okay? If you're given a function, one, make sure what this function is. So make sure it's not a rate function itself. So for the function h of t, if h is the temperature of the oven in Fahrenheit, t is the time. So that means after a certain amount of time, we have a certain temperature. That's it. So at 15 minutes, the temp of the oven is 420. All right. That's for just a regular function. But if you see the prime symbol here, that is a derivative, which means this is a rate. So I should see the word rate in there. So at 43 minutes, spelled correctly, the rate. Now you can say this a couple ways. You could say the rate of change in temperature is negative 11 degrees Fahrenheit. Fahrenheit. Or you could say the rate of change in temperature is decreasing by 11 degrees Fahrenheit. Either is fine, but I need to see rate of change. Okay. I need to see 43 minutes, rate of change. And then again, you could either say is negative 11 degrees Fahrenheit or is decreasing by 11 degrees Fahrenheit. Either is fine. So I'm just going to say is negative 11 degrees Fahrenheit. And you can say rate of change in temperature. I mean, you can make this whatever sentence, but the important things I have underlined, you need to have those when you're given the derivative. Okay. All right, so here's your fun, find derivatives of functions. Okay. You're going to have, power rule, product rule, quotient rule. Okay. Derivatives of trig functions, derivative of natural log functions, derivative of exponential functions. Okay. You're going to have all those. This is going to be, these questions right here are going to fall more on the non-calculator section because you're not actually having to solve for anything. Here's something you may just want to make a little note of. If you're asked to find an actual derivative at a point, like if I give you a number and say find the derivative at this value, and you have a calculator, use the calculator. Okay? Do not, I mean, if you want to do it by hand, the thing is, you're not going to be able to. And I'll show you an example because there's a good example in this little packet here of something you cannot do by hand because you haven't learned it yet. Okay? That's why you're given a calculator and you've learned how to put things in a calculator. Yeah, chain rule. You haven't learned chain rule, unless you have, but even then, I'd be impressed if you did get it right. Okay? So that's why if you have a calculator, use your calculator. This is the benefit of the BC class taking the test before you guys, because I can see what they do wrong and warn you about it. Okay? So, all right. It changes every year. It's ridiculous. So, also, I don't get the same test every year. All right. So we have 4 minus, okay, 1/2 x to the negative 2 is how you want to rewrite that. So now we can just do the power rule. What's the derivative for? 0. So bring down the -2. We get negative half times -2 gives you +1. X to the -3, which you could write this 1 over x cubed.
Okay, so when x one is in the denominator, and when you like flip it, it's all in the numerator.
Mm-hmm. So if we have a radical, we're going to rewrite this as 3x to the 1/2 power minus 6x to the -2 power. And I don't care about 5 pi cubed, because when we do the derivative, it's going to go away. Pi cubed is a constant. So g prime of x will be 3/2 x to the -1/2 plus 12x to the -3, or you can write that as 3 over 2 squared of x plus 12 over x cubed. Yeah. Next one's pretty nice. H prime of x is 4e to the x plus 2 sine x. And that's it.
We don't simplify down the.
There's no way to simplify that.
I thought because.
You can factor out a 2 if you want, but there's no point. The only reason you want to factor something out is if you can cancel. And there's nothing to cancel here. All right, so on to product rule, where we have f and we have g. F prime would be 2t, and g prime would be cosine t. So f prime, so t, is 2t sine of t plus ft squared cosine t. And that's it. Nothing to simplify, nothing to do. You're done. So here for number 9, f is equal to 3t to the 1/2. G is the natural log of t. That means that f prime would be what? 3/2 x to the, or t to the -1/2. And g prime would be 1 over t. So d prime t is equal to f prime, 3 over 2 t to the -1/2, times g, natural log of t, plus f, which is 3t to the 1/2, times 1 over t. So, simplifying that, this can go down to the, okay, come on, let me write. The denominator, we have 3 natural log of t in the numerator, and 2 square root of t in the denominator, plus 3 square root of t in the numerator over t. And if you wanted to simplify this part, you could. You don't have to. And what I mean by that is if you wanted to write that as just 3 over the square root of t, you could. You don't have to, though. I'm fine with it as it is. Right. These are some really good examples of what you're going to see on the non-calculator section. All right. So we have 4x to the -1 minus secant x. So that would be -4x to the -2, or y prime is equal to that. And secant is what? Secant x tangent x? So negative 4 over x squared minus secant x tangent x. All right, and for 11, we have f and we have g. So f prime is negative 1 and g prime is just 1. Okay.
So let's simplify them in more, like, you like the, and those are something like,
If you could, if I had like was it a cosecant times tangent? Yes, you could simplify that because then the signs would cancel. Or if I had cosine times tangent, then yeah, I'd want to simplify that because the cosines would cancel.
denominator.
Yeah.
So
Yeah, there's nothing to cancel out, nothing to reduce, so I'd leave that as it is. I mean, if you wrote it as like sine over cosine squared, I mean, you could, that'd be fine. Just that's more work than you really need to do. Yeah.
for the answer for 20, do you want it, like, just say equals the derivative of y or d of y over d of x? Okay.
so there's no points taken off if it's
None.
prime.
None whatsoever. They just both the same thing. You'll find that when we do like, did we do implicit differentiation? I don't think we've done implicit differentiation. There's a way to interchange. So if you want to interchange dy dx with y prime or f prime of x, it's all the same thing. There are some instances where you're going to want to use dy dx.
And it'll sell you equals.
No, no. So no, it won't. But the context of the question should give you the idea. So, and mainly the only time I really want to use dy dx, we do it with implicit differentiation, even though usually in the past I don't. I usually use y prime because I think it's easier. But the reason why this year I'm going to kind of focus more on the dy dx is because in chapter 4 we will do related rates, and they really want to use the dy dx in that, and it's a really good idea too, because in some cases you will have multiple variables, not just x and y. You'll have a, b, and c. X, y, z. You'll have several variables, and in order to not just have like z prime, y prime, and whatever that is, you're going to want to have that rate. Okay. So number 11. Here we have f and g, and f prime and g prime. Should make this easy. So f prime g should be x plus 2 minus g prime f 2 minus x over x plus 2 squared. Now here, the minus 2 should cancel. I end up with net 2x over x plus 2 squared.
F prime.
Oh, it should be negative, shouldn't it? Oh, yeah. So that should make the x cancel, and you end up with negative 4, right? There we go. Good catch.
So next one, the probable and the possible, like the top of them like this, doesn't matter if the f and the g like.
Doesn't matter where you put them in. The only thing, like if you have f prime g minus g prime f, or if you have f prime g minus f g prime, it's not important because it's multiplication. What does it matter in multiplication? What does matter is that f prime g is first and g prime f is second. That's the only part that matters.
Oh, that lets both of us.
Yeah.
Okay.
So the order of multiplication doesn't matter, but the order of the subtraction does. All right. Now, on this question, it does say find the equation tangent line at a given value. Let me check to make sure this is going to be part of. Yeah, that's part of the no calculator section, so you will have to do this by hand. So first, we need a coordinate, because if we want the equation tangent line, we need an x, y. We do know what x is negative 1, so we need to plug that in to find y. So negative 1, if I plug in negative 1, I get 2 minus 3. So negative 1, okay. And then I do the derivative. Okay, so f prime of x, easy enough, is negative 6x squared plus 3. So f prime of negative 1 is negative 6 times negative 1 squared plus 3, which gives you negative 3. So I use my slope-intercept form. Y minus y1 is equal to my slope times x minus x1. Do not do any more work than that. I'm going to have all my answers in point-slope form. If you put in slope-intercept form, it'll more likely just annoy me. Okay? So you probably don't want to annoy the guy grading your tests. Not that I'm petty, but I'm pretty petty. All right. Yeah. It's just there's just no point. There's no point. You put in point slope form, everybody accepts point slope form on the AP test. They want point slope form. Leave it in point slope form. Don't do more work. You don't have time for it anyway because tomorrow's a shorter day.
We're going with the calculator section.
I'll talk to you guys when we're done with that because I think tomorrow is the calculator section. I just don't know which one takes longer. The non-calculator section usually has easier questions. Usually. But I see right now they're all the same. Alright, so pi, and if I plug in pi, sine of pi is 0. So 0 minus 2 is negative 2. So f prime of x would be 4 cosine x, because the 2 just drops. So f prime of pi would be 4 times negative 1, or just negative 4. So there's my slope. So y minus a negative 2 is equal to negative 4 times x minus pi. Now, you will not be asked for a normal line on the test.
It's the exact same as a tangent line. It's just reciprocal.
Yeah. You remember parallel perpendicular lines? Yeah, you basically find the slope of the tangent line and then do the negative reciprocal. Do that perpendicular slope to that. That's the only difference between normal and tangent line. It's all the same thing. It's just once you find your slope, you flip the fraction, change the sign. There's your normal slope. But it's not going to be on your test, so I'm just not going to worry about it. Yeah. No. Now, this you can do without a calculator. So it does say no calculator. So f prime of x is 3 cosine of x minus 2e to the x. That's the derivative, right? So if we want f prime of 0, we just plug in 0. What is cosine of 0? 1, so cosine of 0, and anything to 0 power, so it's minus e to the 0. So this gives you 3 times 1 minus 2 times 1, so 3 minus 2 is 1. Now, notice you don't have a lot of room to work 16, 17 out. It's because you can't. You cannot. This is chain rule. How do you know this is chain rule? I have a function inside of a function. If I have a composite function, you have not learned how to do derivatives of composite functions. Okay? So, just plug this in a calculator. You should get 260.246 and negative 36.899. You just plug them in a calculator. Do not do any more work than that. And again, even if you were given this on the section that had a calculator, plug it into a calculator. Do not waste your time. I do believe that tomorrow, the first half of the test is the calculator section.
It's like a bundle.
So, yeah, the first half is calculator section. Not everything on the calculator section will require a calculator. Okay? But some things will be, specifically these right here. Okay? Yep.
I know.
Well, say radian, I mean, that's.
Choose calculators in radians, yes. Always. Your calculator should not be out of radians for any reason.
It isn't radians.
You got.
Ah, 120 falls between these two. All it is slope. So that is 808 minus 412 over 180 minus 60. Which if you put this, I mean, if you have a calculator, put in your calculator, you get 3.3. Now don't forget, feet per second. If you're missing the units, you will lose a point.
Really can't see. So the tower doesn't stop, it doesn't do another thing.
So I get.
Oh, no, Jesus. It's with the slot, it's like.
So this question, all right, 19 and 20 are kind of the same question. It's just 19, you're finding value for A and B. That will be in your test. Just 19. 19 may be in your test.
Said I know.
Well, 20 is going to be in your test, definitely. 19, I'm not certain. But you do them both the same way, so it's good practice. First, what do we check for? Continuity. As I write continuity up there, yes. So that means I plug in 2. That means that 3 times 2 minus 3 times 2 squared minus 5 must equal 7 minus 9 times 2. That's how we check continuity. So it gives you what? 6 minus 12 minus 5 is equal to 7 minus 18. So we get what? Negative 11 is equal to negative 11. So yeah, continuity works. All right, then we find f prime of x, which is 3 minus 2x, 3 minus 6x, and negative 9. So, does 3 minus 6 times 2 equal negative 9? Does 3 minus 12 equal negative 9? Yeah. So, therefore, it is differentiable at x equals 2.
If we go up there non-continuous, like right there, and you see non-continuous in the notes.
That's it. Well, not continuous means not differentiable. Yeah. Okay, pretty good. Okay. So, for number 20, same stuff. Continuity. So that means that a times the square root of 4 plus b times 4 squared, or 4 squared times b, minus 1 should equal 16 over 4 plus 4 times b. So 2a plus 16b minus 1 should equal 4 plus 4b. Okay. We can simplify this, so 2a plus 12b must equal 5. And we'll leave that alone. So f prime of x is equal to, it's a little fun, we get 1/2 times a times x to the negative 1/2 plus 2b, and we get negative 16 over x squared plus b. So if you want to write that as a over 2 squared of x plus 2b must equal, oh yes, thank you, x squared plus b. There you go. So checking for differentiability, that means a over 2 square root of 4 plus 2 times 4 times b. That needs to equal negative 16 over 4 squared plus b. So that is a over 4 plus 8b equals negative 1 plus b. And to make this easier, we can just multiply everything by 4. Well, guess what we have now? System of equations. Now, I'm going to tell you this up front. This question is harder than the one in the test. Test is a whole lot easier than this. You do not, I mean, you do get a system of equations, but really, I think after you do the derivative, you're left with just a single variable. All right, so you're left with a single variable, so you're given either a or b, and then you plug it in to find a or b in the other equation. Okay, so it really isn't that bad. Now, what I'm going to do is multiply this over here by negative 2, so I can cancel out the a's.
Equals an A and plug it in 3.
You could. I just prefer elimination method. That's gone. We get what? Negative 44 over 13. So that's lovely. B is equal to 13 over negative 44. Just pretty right there. All right. All right, now this A. Yeah. Yeah, that's what you get. So plug it in. Since we have A over here by itself, A is equal to negative 4 minus 28B. So that is negative 4 minus 28 times 13 over negative 44. And here's just a lovely thing about calculators. Negative 4 minus 28 times 13 divided by negative 44. Math, fraction, enter. That's. I didn't type it in right, so that's why. That should be times. 47 over 11. Yeah, for A. It does help if you type in your calculator correctly, yes. So, I like to give little hints like that.
Oh.
Is that it? Is that it for the review? Okay. So that's it for the review. What I'm going to do is go to the homework packet and then highlight some things that are in the homework packet you may want to focus on.
I
You should.
Partially.
don't even have a little. I don't know. Let me call it. Sorry. Wait, almost. I'm just gonna have a.
So let's see here. All right. Okay. This question. This is in the very first homework, 2.1, 9, 10, no, not 9, 10, 12, 13, 14. Okay, find the average rate of change of something like this. Let's start with let's all right, do what else? These questions right here, where you're given a graph and you need to locate where a function is either not continuous or not differentiable. Okay.
Did you say
So this is 2-4, first few questions here. So 2-4, questions 1, 2, and 3.
You said 32 on 2.1? No,
I think 12 through 14 was it? So
I think I heard you say.
just want to make sure something.
No. Yeah.
Oh, it's that. Um, let's go to the last few sections, which was 2.8, 2.9. Yeah. These questions right here on 2.8, 11, 12, 13. Okay. And the same questions on 2.9, but where they give you this chart and they give you some combination of functions. So this is 2.8, 11, 12, and 13. You will have these questions on your test. All right, and then 2.9. 2.9, that is 10, 11, 12. So these questions, again, it's the same kind of questions. So I'd practice those, make sure you can do those. Number 19 on the review, that will be on your test. It's just on the non-calculator section. Number 19, you will have question like 20 and 19. Number 20 is on the calculator version. 19 is on the non-calculator version. That's on the review. Yeah, so number 19 is on the non-calculator section. Number 20 is on the calculator section.
I don't know if I bought it originally. Within one.
You will have some review questions. Okay, specifically dealing with limits.
You like teleport.
You're gonna kind of always have limits reviews on your test. So you're always gonna have at least one or two questions going back to previous sections. So yeah, know your rules for horizontal asymptotes based on your limit functions.
I think it's
Well, you gotta remember which, like, depending on your function, is your function getting bigger or getting smaller? Okay, you're gonna have to really think this one through. Okay, you're gonna have to really think this one through. Oh, 2-4 again.
I checked my homework with everyone that. Okay.
Yes.
no like learnings.
For sine code for all the trig functions, I'll check homework in a bit. So yeah.
That's true.
I'll check homework in a bit.
I know that.
Plus, I will check homework later.
And then
Mark it down for missing.
Today's not the day of the test. Just give it to me tomorrow when you take the test. Keep it tonight. Honestly, I don't see a lot of 210 on this test. Know your sine and cosine, and know your tangent. I do not see a lot of secant, cosecant, cotangent, if any.
I'll mention my voice to
All right, but really, again, go over the homework. You should be okay.
That's a homework.
I will check homework later. Okay. All right. Make sure I got everything.
said not a lot of seeking.
I just know your sine, cosine, tangent. All right.
Okay.
Everything else should be something you should be able to reasonably think through. Oh wait, I didn't see that question first.
Pardon?
I don't. That question. No. Yeah. Yeah.
And pretty much do it.
See, excuse me.
I don't know. Sam, I have one house. Second one. So I don't see. I was built, yeah, my. I don't know. All my need. I did a lot from it. Yeah, I can't go up and then show them house.
Ugly jerk. you go ahead. You know, I'm accepting of it. I don't want without one time. And then you you didn't love it. You want it, right? Well, in there, like. In the moment of truth. Even if it's phone, you really, I'm not going to prove my that.
I'm still kind of confused on these with the quotient rule where you have to plug it in. So like I write out the quotient rule without plugging it in.
Yeah.
It's like for here I get f prime of x, so I just plug in this.
Plug in 3.
Okay, so where are the x's going to be that I plug in the 7?
These are all 7. That's f prime of 7. That's f of 7.
Oh, alright, so I won't actually plug 7 in.
Nope. Unless you see something. Oh. You have to be careful because unless you see something like that f is equal to x plus t, okay, because then you will have to plug in whatever number for that. If you see it outside of the function
If
notation,
it's like a different,
if it's not within a function notation, you will have to plug it in.
okay. Yeah.
Why you like?